Mazzei injector. It was started by Angelo Mazzei back in 1978 in his garage. And he came across an idea of using Venturi injectors to inject fertilizer and nutrients into irrigation water. At the time, the Central Aqueduct project in California was taking place, and he realized to pump against pressure, to pump against 60 psi might cause problems if you're trying to pump in it. So he figured that he would develop a way to use the motive force of the water to actually create a Venturi effect to suck in the nutrients and fertilizers into it. So we're recently, back in 2018, we celebrated our 40th anniversary. We're going on our 45th year, and I'll talk a bit about how it's grown. So from the one market, from the irrigation market, we've grown into all these other markets, into bottled water, into pool and spa, into wine, into produced water for the oil and gas market, for municipal drinking and wastewater treatment, and industrial water and wastewater treatment. And I'll go into some of those as well. So again, here's the markets: agriculture. We're doing a lot in aquariums and aquaculture, food processing and bottled water, as I mentioned, industrial water and wastewater. And again, that includes produced water for the oil and gas market, and then municipal water and wastewater. And so again, here's some of the things we're doing. And one of the things we're particularly good at is putting oxygen species into water. And so it's easy to get a lot of gases into water, carbon dioxide, some of the other gases, but oxygen is particularly problematic. And so we're really good at putting in air for dissolved oxygen, pure oxygen. I'll talk a little bit more about that, why that's important, and then ozone, O3. So those three things, and most of my presentation is going to be talking about the ability to put gas, mostly these oxygen species, into the water. And so for aeration, we're looking at odor control, biochemical oxygen demand reduction, post-treatment of effluent water, and then taste and odor for ozone, disinfection, why ozone is a good disinfectant, ozone for some industrial applications, and then there's some mixing applications. I'll talk about the different types of products that we produce for those above and beyond the Venturi injection. So here's a look at some of the products. Most of it is based around the Venturi injection, but there's some secondary mixing devices, there's degas separators, and then of course to control all these products, we do produce a number of skids, and I'll show those as well. So a little bit about how these the Venturi works. As I mentioned, it's a Venturi system that uses the motive force. Basically, you're taking the flow of the water and you're restricting it at that at this point where the water comes in contact with the gas. And so by increasing the velocity at that restriction, you're increasing the ability to suck gas into the Venturi. And we do a lot of work with computational fluid dynamic modeling. And this is just a little rendering, an animation of the way it works. So the water flows at that restriction, you've got the input of the gas. And the other thing good about a Venturi system is that not only does it suck in the gas, but it does a really good job of mixing that gas in with the water. Because at the end of the day, you're producing that gas, whether it's air, whether it's pure oxygen, whether it's ozone, and you really need to get it a homogeneous mixture so that it can do its job in whatever application you're looking at. So you've got a Venturi injector, and in most cases in our applications, you want a secondary mixing device. So there's a number of different ways we're going to show how to do that. So we've got a pipeline flash reactor, which I'll show an animation shortly on how that really works and does a good job of really taking that mixed gas liquid mixture and mixing it back into the main line without using a basin. We have basin nozzle manifolds, which you can use in a basin instead of, say, something like a fine bubble diffusers or coarse bubble diffusers. And then we've got a modified pipeline nozzle manifold, a little simpler technology than a pipeline flash reactor. We're doing a lot of work around using this to get air into systems for iron and manganese precipitation, where you can filter them out a lot better than some of the other types of ways to do that. And then we're also doing this in some horticultural projects where we're putting ozone or oxygen into vertical farms or greenhouses.